2009 IECC as a rater and doing code compliance with builder clients. And then I got involved in code development in the 2015 cycle.
Fantastic. So our session today is on the 2024 IECC. Aren't you excited you came to a code session first thing in the morning? It is so exciting. So key things that we're going to be talking about, how the 2024 development process changed from previous years. There was a big change after the outcome of the 2021. We'll talk about that. We'll talk through some of the major changes, not all of the changes, but some of the big ones for the 2024 IECC compared to the 2021. And then we'll talk about some of the federal reactions to the 2024. How are programs like USDA, HUD, VA, and IRA funding reacting to the 2024? And then we're going to finish up with 2021 versus 2024. And I say versus, it's not really a versus, but it is trying to understand what's going to be best for your jurisdiction. What do you think you should be pushing for locally? Go from there. So the 2024 is very different in a lot of ways from the 2021. One of the key changes is how it was developed. This is in my opinion, a big pendulum swing from what happened at the end of the 2021 development process. And so this is really switching from the traditional governmental approach where there's 2-minute testimony on code cycle or code proposals and back and forth in front of the committee to a more consensus development standard. And it's, I think, important to note, this is the same way that ASHRAE 90.1 and 90.2 are developed. So it's not that unusual for a code to be developed this way. So in the 2024 cycle, there was 48 members on the consensus committee, and I think over 150 on appropriate subcommittees related to that. I don't know, Robbie, were you on a subcommittee?
Yeah, I was on the existing home chapter subcommittee.
Fantastic.
And just to add to that real quick, in the code world, it was a pretty big change, even though it was very similar to ASHRAE standards and whatnot. But in the normal code world, you do development through the code hearings, and the code hearings is as Nathan was saying, is kind of this 2-minute process where you put in a proposal and then you have 2 minutes to speak to it. Then people have 2 minutes to rebut, and then you can rebut once there, and you kind of go back and forth. And it's basically up or down pretty much after that 2 minutes. It's a little bit longer process, but the consensus process is good and bad in certain ways. One is that from the bad side, it's just super time consuming versus kind of a dedicated 2-week process at the code hearings. The consensus process was good 6 months or longer. With hours during the week. I mean, it was probably 8 to 16 hours a week you're dedicating to that there. So, but that was also good in some ways because proposals didn't necessarily die at the podium. They could be massaged a little bit during the process. So.
Yeah, absolutely. So, looking at how that process works. We're going to go high level, not into all of the details of this, but really people apply to be on a consensus committee or a appropriate subcommittee. I think there were 5 subcommittees in this last cycle. I expect there to be about the same number in this one. During that time, ICC says, okay, start submitting proposals. We'll start gathering those together, and then that goes to subcommittees. Subcommittees do a lot of the work for the code development. They will review all of the proposals, talk them through, decide if they need modifications or changes, and then they will make recommendations to the full consensus committee to say, yes, vote this up or vote it down. After that, the consensus committee will review the recommendations, vote on changes. Sometimes those votes are
going to be published, there was a lot of consensus building, a lot of trading of ideas and trading of positions and compromise that was made. And it resulted in what was called a omnibus proposal that kind of incorporated all of these things into one thing. And they basically moved this section, but it didn't interact, and what they didn't address those other issues that were compromised in order to put these things into the code. So some people are quite upset about that, and one quick example of that is if you've looked at the 2021, you'll see in Climate Zone 5 that it requires an R60 attic in the prescriptive R value table. In the 2024, it got dropped down to R49, back to the way it was. That was part of this proposal, but they changed these things or moved these things to the appendix, but they didn't raise the R value back up to R60, for example.
Yes, so I think there's some credibility building to be done, and we've seen the 2027 development cycle has already started. The IECC Board of Directors put out a draft scope of intent for public comment. That scope and intent is very in line with the decision-making that was made around the appeals, focusing the code solely on, at least the base mandatory sections of the code, on energy conservation opportunities only, and putting items around resiliency, greenhouse gas emissions into optional sections such as R408, which we're going to talk about more, and or to an appendices. So that's still, that has been finalized, and proposals for the 2027 will be opening next week. And I will be interested to see how this impacts the development cycle, how this impacts participation from typical stakeholders throughout the code process, and where we're going to end up for the 2027. So I think enough on the cycle and appeals. Let's talk about the changes. This is probably what most of you came here to learn about. We're going to cover a lot of the major changes, but not all of them. So the 2024 is publicly available for free online. I strongly recommend, if you have a municipality that is looking to adopt it, go read it, go understand a little bit more about it. There are plenty of resources available from NHB, from the Department of Energy, from several other parties about some of these changes and what the opportunities are under this new code. So we're going to cover some of the high-level ones. We won't be looking at things like existing buildings. I think most of you all are new construction in here, so we will stick to new construction and go from there. Robbie, you want to handle these?
Yeah, so the first things that changed were in the administrative chapter, and a lot of jurisdictions actually don't adopt the administrative chapter, and there's some really interesting and good things in this chapter that municipalities should consider. The first one here is with regards to inspections, and if you look at the codes up until the 2024, you'll see that the inspections have been framed a little bit differently in the context of what you need to look at from the perspective of energy, like that insulation is not only installed to the R value, but it's actually been installed properly so it actually works and functions. And so they did some additional work on that section of inspections to focus it in more and more on energy and air barriers and insulation installation. Approved third-party inspection agencies is something that's kind of been passionate for me, and I was part of the group that worked hard to get some revision of that in the 2024 to be able to better clarify the relationship between the code official and an approved third-party inspection agency, to give that third-party inspection agency basically a scope of work, but also some authority to actually fail an inspection if they're going to be using that third party, and also to better clarify kind of the financial relationship so that it's clear that the third party has the authority to work in that jurisdiction, but the jurisdiction also has the ability to say that you can't work in that jurisdiction and provide documentation for code approval if that jurisdiction feels that there's something that you've done that's compromised your integrity and your independence from the builder that's utilizing you there. And then the installation mark installation, I think this change really happened more in the 2021 cycle where we have this problem with insulation that's installed that doesn't have an R value mark on it. And we really have no idea what the R value is. We can make assumptions of what it is, but it's completely based off of either the density of the blow or the chemical reaction that happens there. And so we're asking now that the insulator basically certify the R value that's installed and provide a certification certificate immediately after the installation of the material. And the hope is, in the vagary of code language, that we get better quality assurance from the actual installer of the material at the time of the installation, and that we can rely on the R values that they're certifying in essence.
Thanks, Robbie. Next big change, sorry this is small. There were some pretty significant changes throughout the R value tables and the U factor tables. So some of the key changes in colder climates, there was ramping down of U factors for windows. Nothing that's going to push a builder into a triple pane, but requiring some better window technology. There was a really great, I think, increase in skylight U factors. Those hadn't been touched significantly in a while, and so bringing them down and making them more reasonable is appropriate. Another key change that Robbie mentioned, if you look at ceiling R values, in 2021, there was a push up in climate zones 2 and 3 to R49, and then 4 through 8, it went up to R60. That came back down as part of that compromise. So that is a significant change. Another key thing that I think is great, and we're trying to recognize more about low-rise multifamily that is covered under the residential provisions of the IRC, is what happens when we have insulation entirely above deck. So these values were added to this table, really trying to bring some better guidance for those low-rise buildings. And then some of the last changes, floor R values didn't really change, but there was some flexibility added into what pathway you can choose. So you can pick a cavity-only insulation option. You can pick a hybrid where you've got a little bit of cavity insulation and some continuous, or you can pick an all-continuous option. And so that was added throughout all of the climate zones. And then another reduction was in the slab edge insulation. So climate zones 4 and 5, taking that from R10 at 4 feet below grade to R10 at 3 feet below grade. So again, this is our prescriptive values. I'm going to assume that most of the people in the room are following a performance pathway, but this will, so you're not always looking at those prescriptive values, but this will inform the reference home that you're comparing against.
The other big change, obviously, was in the structure of the table, which we should point out, too, is that they inverted the XY axis there, so that's why it might look a little strange to you there, but it ultimately makes it easier to read.
Well, and I believe this is more consistent with the commercial sections of the code. It had taken that switch previously, so this just brings some better clarity. Another item that you will see throughout the code is F factors are in the code now. Basically, there's U factors, F factors, and C factors. U factors are for above grade walls, but we had been using them for slab edge insulation. The change is that really F factor is the appropriate heat loss, heat transmission factor for slab on grade. So that was changed in the U factor table for the slab edge and the below slab insulation values. And there was actually an appendix brought in that gives a lot of great information about some of these factors.
Yeah, just as a reminder, U factor, F factor, and C factor are talking about basically the resistance of heat flow through an assembly of things versus R value, which is the actual component there. So this is super important because you might have noticed that if you use the ResCheck software for the area-weighted U-value approach, that PNNL stopped you in the 2021 from being able to do slab edge trade-offs because there was no value, there was no assembly value there that they could use in the U-factor table because all the U-factors are what's basically populating the softwares for the software modeling there. So now that ability to get more flexibility whenever you use even a limited energy model versus the more sophisticated energy models has been brought back into the code.
And with the change and addition of F-factors, they had to change the name of the UA alternative. Since we have F-factors in there, calling it a UA is not appropriate. So the name was changed to the Component Performance Alternative, or TC, so total conductance, total conductance, I think. Yeah, it's now referred to throughout the code as TC instead of UA. So you may see us talk about TC on future slides. That's what we were talking about. Other changes that happened were changes in the specific installation requirements. So there was, it was always implied for attic knee walls that they were supposed to be installed like typical above grade walls, but it wasn't really confirmed. So that was a change to verify and provide that requirement that attic knee walls need to be installed like above grade walls. Another change throughout that section is that for slabs, crawl space walls, and basements, there was specific language put in that is saying you install it this way or you install it in accordance with your energy model. So they're saying in accordance with the proposed design or rated design as applicable. So if you're unable to get insulation all the way up to the top of the slab edge, you can model it and take the hit in the model, and that meets the requirements. There is also things for basement walls if you're not installing insulation all the way from the top of the basement wall to the bottom of the basement wall. This is something we might see with some code minimum production builders. That is going to be allowed as long as you're performing or marking that in your model appropriately. So that's a big change.
I think the big thing to recognize with regards to the specific installation requirements is that they're requirements for how you install a product or an installation. Sometimes there's mixed in there R value and U value ability to do some trade-offs utilizing the prescriptive R value table, but mostly it's about how you install things. So when you, for example, are looking at the R value table, it doesn't say that you have to put in that R value. Basically, you have the ability to do what we call a trade-off using an approach. But for attic knee walls, for example, we often see that an attic knee wall is framed with a 2x4 wall, but the rest of the exterior wall is framed with a 2x6 wall, and that's perfectly fine. It just means that you can't use the prescriptive R value compliance approach. You've got to move to a different approach, and that I think these kinds of upgrades to the code help point those types of things out a little bit better.
Absolutely. Another major change that we saw is a change in air leakage rates. So for climate zone 0 through 2, it dropped from 5 ACH50 down to 4 ACH50. I think that's a very doable reduction for most of the buildings in those climate zones. Climate zones 3 through 5 stayed the same at 3 ACH50, but then climate zones 6 through 8 dropped to 2.5 ACH50, so that is a reduction for those colder climate zones, recognizing that they have more intense heating requirements, and so they need to be slightly tighter. Another big change was shell area had been included in the 2021, but in some ways it wasn't as well defined on how you use it, where you use it, and what your overall application of it should be.
So they were very specific in rewriting that section to say how you use it and where you use it. So you can use the shell area leakage rate of 0.27 CFM for duplexes, any sort of R2 occupancy, or for single-family buildings that are smaller than 150 square feet, or sorry, 1,500 square feet. And then they also provided some clarification about guarded blower door testing, which is especially important in attached buildings. Basically saying if you are using guarded testing where you may have multiple blower doors operating at the same time, that is allowed, but you do need to make sure that you're reducing your shell area appropriately. If you're trying to equalize units on either side of a townhome, great, that's allowed, but you need to pull that shell area out so that you're only looking at exterior walls at that point.
The other good thing that happened in this section is if you look in the 2021 IECC, the first thing you'll see is that you're allowed to go to 5 air changes in climate zones, basically in climate zones 3 through 5. So everyone thought that there was kind of this rollback, and in reality, they didn't write it very well, but it's only allowed using a performance compliance approach, using an energy modeling compliance approach, which means that it was kind of this perverse backstop saying that I'm going to put in more insulation somewhere else so that I could trade off for higher air leakage, which really is not how I've seen a builder ever do that. And in the 2024, they made it much more clear that there are air leakage allowances for the 4 different compliance approaches, so that you still have, in essence, this backstop for air leakage in the performance approaches, and then you have these listed air leakage rates per climate zone if you choose to use the prescriptive compliance approach.
There were also significant changes throughout R403. This is talking about HVAC systems and plumbing systems. Some of the high-level ones, the heat pump supplementary heat options previously only referred to electric resistance heating. It now includes references to fossil fuel systems. So if you've got a dual fuel system, it's being very clear on when that furnace or other fossil fuel system should kick in, and set some really key limits around that. Also included in previous codes, we've seen a requirement to complete a manual J, heat load calc, everybody should know that, and a manual S to confirm that our equipment is sized appropriately to meet the load. But a big change that we're now seeing is the inclusion of manual D, having a duct design as part of your overall code compliance package so that your system can actually distribute the heat appropriately and handle this. Another big change, oh, and I have pictures for all of these, sorry, sorry, this is one of my joke pictures. We started installing ERVs at one point, and I come in and see this nice control wire, and I'm looking at it, and I see ARV, and I'm like, what are they talking about? They just misheard us pronounce ERV. So ERVs are now required in Climate Zone 6. Previously, it was only required in Climate Zone 7 and 8, so that was brought down to Climate Zone 6, really expanding the area where ERVs and HRVs are going to be used. And then 2 other changes, putting limits on electric resistance space heating. So saying that you can only put so much electric resistance unless you also add in a heat pump. So a big opportunity to reduce that low efficiency heating. And then there was requirements for controls for, it's listed as intermittent exhaust fans. These are fans used in bathrooms and other wet areas, but putting requirements to say they either need a timer, occupancy sensor, humidity control, or contaminant control. So go talk with some of our great sponsors here about what that would look like to implement on your fans. Robbie, anything else on this?
I'll just add, because I'm particularly passionate about duct leakage. So in the 2021 IECC, you'll see that you have to test ducts for duct leakage regardless of where the ducts are located, which is new to that code. But you do get some allowance if all the ducts are located inside the conditioned space, and those allowances have been added to this table, and it expanded on a little bit to make it more clear that, yes, you still have to test the ducts regardless of where they're located, but they get tested to different leakage targets, in essence, that are listed in this table. That's new to the 2024.
I think a big piece on this table is this far column. Any of you who have done duct testing on ADUs, on apartments, on small buildings that are below 1,000 square feet have felt the pain of trying to hit a requirement of 4 CFM per square foot when you only have 750 square feet. That gets really difficult. So they've changed this to, instead of being based on the square feet of conditioned area, to just a hard target for these smaller units. So I think that's going to provide some good flexibility while still keeping good stringency around all of this. Another option that's brought into the code, this will be valuable for any multifamily builders in the room, is the opportunity to do unit sampling for your testing. So there are 3 tests that are going to have to be done on every home: blower door test, duct leakage test, and a ventilation test. What the code is allowing is for buildings with 8 units or more, you can start to look at sampling. It's going to require a minimum of 7 units, so if you have an 8-unit building, go ahead and test that 8th one. Like, there's no point in not testing it. So it sets these requirements on how you should test, what percentage of the homes you should test, and then what to do if you have a failure. So adding more units into your sample. This is consistent with some of the language that ResNet has been allowing around sampling for HERS rating, and I think limiting it specifically to attached units that are larger makes more sense than allowing this in single family.
Yeah, and I don't know if everybody's aware, but in the 2021 IECC, this is when the ventilation testing got into the code or was added to the code. So you're talking about measuring the flow rates for whole house controlled mechanical ventilation, spot ventilation in bathrooms, kitchens, and laundries, and also ventilation of kitchens through kitchen hoods there.
So other key changes are around interior lighting, and I think then we'll get to the end of some of our prescriptive requirements. The code changed the language to say 100% of lighting must meet a certain efficacy. So they're saying for luminaires, for the non-lighting designers in the room, that is what I would call a lamp. It is your fixtures, that is your luminaire. They have to have a efficiency of 45 lumens per watt or greater. And then for lamps, this is what I call a bulb, but what lighting designers are adamant that they are called lamps, have to be at an efficiency of 65 lumens per watt or greater. There was also, in the 2021, there was this requirement for interior lighting controls that came into the code. This was changed in 2024 to really specify what types of controls should be in what locations. So for most locations throughout the home, they're saying a manual dimmer or what is referred to in the control as automatic shut-off control. This is a fancy way to say an occupancy sensor that will turn off when you're not in the room. That is a dimmer or occupancy sensor is appropriate for most of the spaces, but then there are specific areas that may typically be unoccupied that only an automatic shut-off control is allowed. This is a garage, laundry room, utility room, unfinished basement. These areas that you may not typically go into are going to require these automatic shut-off controls.
And because the residential side deals with single-family homes, duplexes, townhouses, and multifamily that's 3 stories or less, this section might look a little bit daunting, but when you read it, you have to understand what's being required in more of the multifamily, stacked multifamily, versus what's required in kind of the detached single-family houses. So it's not quite as daunting as you might think.
Yes, you'll see a table that came over from the commercial section for those R2 occupancy buildings, but know that that is just for multifamily. It's not a requirement for single family. And then finally, there was a big change in section R408. This came about in 2021 as a additional efficiency measure system. So there were 5 measures, and you went and picked one, and that was your option to do throughout the code process. This has changed pretty significantly under the 2024. It changed from an individual measure selection to a credit system. So there are about 50 measures, a little over 50 measures that you can select from. Each of them have different point values based on the credit or the specific measure and the climate zone that it's in. And I'll show a sample of that table in a second. And so the requirement is for most homes, you have to get a minimum of 10 credits or implement minimum of 10 credits, and that has to be between 2 measures. So you can't just pick 1 credit, you have to pick 2 and get all of them. So some of the areas that it looks at, things like your equipment, whether that's heating and cooling equipment, water heating, there's a lot of opportunities around ducts and conditioned space to get some significant credits. Air sealing, ventilation, renewables, all of these are options under the code. And so this is an example. This is the very top of the table. You can see you can get different credits based on your percent reduction in total TC. That's what was formerly known as total UA. So you have options to get points throughout all of these. And so typically, depending on the credit, a lot of these can be combined. There's some of them that are additive of each other, like these TC. You can't get credit for being 2.5% and 5% and 7.5% above the code. You can only get one of those. And then I think the last thing to say about R408 is that this only applies to the prescriptive code section. It does not apply to the simulated performance or ERI pathways. The way that this was implemented is that when you look at these credit tables, each credit is about 1%. There's some rounding going on, but it's about 1% improvement in energy efficiency. So that allows some comparison to the efficiency requirements in the performance and ERI paths. So those requirements were adjusted appropriately there. I think in the 2021, there was some confusion on how to implement the additional efficiency section in a modeled pathway. So this really helps that out and allows for some different flexibility options under the prescriptive path, but then also allows you to have that clarity for the performance pathways.
And you'll see in the performance pathways that they have what has been added, these things called backstops. So in the performance path, there's an envelope backstop that ensures that you have a sound building thermal envelope before you take into account maybe renewables or other things that can swing depending on the pathway that you're using there. I forgot what else I was going to say.
So, sorry, these are I think the major changes for R405. Robbie mentioned backstops. Key things is that they set a thermal backstop based on this TC, the thermal conductance. So for climate zone 0 through 2, your proposed design has to be better than or equal to 1.08 times the prescriptive reference. So 8% over that. And then in the colder climate zones, that is at 15%. So this allows some flexibility, but it also ensures that these long-term durable performance aspects of the home are not going to be missed.
Yeah. Real quick, I remember what I was going to say with regards to the additional efficiency options and the table. So if you haven't looked at the 2021, that's when that concept first got into the code. And in essence, what we're dealing with is that there are substantial diminishing returns to just decreasing R values and over time and whatnot. I think we still can get some benefit from lowering air leakage and those types of things, but there's a desire to continue to increase the overall efficiency of the home, and so the approach of doing these additional efficiency packages have come into the code, and it started in the 2021 there. And roughly, those packages are equivalent to about a 5% increase in efficiency. And you can see that the options have been expanded so much more in the 2024, and now they're looking for roughly a 10% increase, which is roughly equivalent to what's going on here with these backstops.
And then we'll see for the 2027, I think that's going to be one of the big debates is what is the next amount of points? Is it 15 points? Is it 20? What makes sense? And what can we cost effectively do? So that will be, I see a key opportunity to increase efficiency of the code through these R408 measures. So it's, can we expand the table, include more measures, and also look at different credit amounts? Another key change, if you are familiar with the performance path, you know that in previous code cycles, you needed to be at or better than the cost of that reference home. This has changed under the 2024 for several reasons. One, to increase efficiency, and then also to put mixed fuel homes and all electric homes on a more level set. So it's requiring that you be at 80% of the cost of the reference home for mixed fuel and 85% of the cost of the reference home for an all-electric home. And then it also includes a bump for an additional 5% if your home goes above 5,000 square feet. And this is not 5,000 square feet of conditioned space. This is 5,000 square feet of living space above the grade plane. That is a new requirement or new phrasing that was brought into the 2024 to look at this. So you wouldn't be penalized for things like unfinished basements that are maybe in conditioned space but not above the grade plane or not typical living space. And then it also includes options for source or site energy and some sources that you should go to find those. Anything else about this, Robbie? Yeah, so again, looking at a typical report, you might see that you are at or better. Now it's trying to get to that 80 or 85%. Oh, and my, let's see, my, yeah, animations are off. Sorry. Basically, another big change in the performance path is that the reference home has changed pretty significantly. They looked at all of the typical equipment, and so in previous versions of the code, the reference home was based off of the as-designed equipment. That has been changed to the minimum federal efficiency requirements. So the key takeaway with this is that you can now get more credit for installing higher performance equipment. So you can make better trade-offs around equipment at this point than you could in previous code cycles. I think we're still trying to see where or how this is going to impact the reference home and impact modeling to see where everything kind of shakes out. And so I'm looking forward to the software providers getting out new versions of the code so we can start looking at that.
I think that's going to be crucial. I used to always say that the simulated building performance approach was the most flexible approach that builders could use to get code compliance, and we just don't know now the effect.
Yeah. So again, there's some increased flexibility with these changes, but we also just don't know where we're going to end up. Another change, we talked about equipment being changed in the reference home. They also changed ductwork in the reference home. So what they've done is set standard duct locations based on your foundations and number of stories. So if you're slab on grade, one-story building, the assumption is that 100% of the ductwork is going to be in that unconditioned attic. If you go up to a two-story, it's assuming that about 25% is going to be in conditioned space and 75% is going to be in the attic. Again, the key opportunity is that you can get credit for bringing ducts into conditioned space and improving beyond what's listed in that reference home. So again, we've talked about performance path. Let's talk about the energy rating index pathway. Key things, they have included the same envelope backstop as was in R405. It's that %TC. And then they also removed, I think, a really important change. There was alternate ventilation requirements for the what I would refer to as the IECC ERI versus the HERS ERI that was listed in ResNet 301. They've removed that change, so there's more consistency between a ResNet HERS index and an ERI that you would calculate for the energy code.
But remember that those two numbers, there is a separate IECC Energy Rating Index number for the same house. If you were to do a ResNet HERS Energy Rating Index, those two numbers will never be the same. They've gotten a lot more close, but because of the code basically referencing a specific year of the ANSI 301 standard for how you generate an energy rating index, and ResNet being on a continual pathway of development and adoption of the standards, they will never be exactly the same.
Then another key change was changing to this energy rating index table. So basically, in the 2021, there was an option to include solar in your ERI, but it was a little confusing, and how that was supposed to be implemented wasn't always the most clear. So what was basically changed in the 2024 was to say we're going to have two metrics. One, ERI, if you're not including on-site power, and then one, if you are including on-site power production. So you'll see these higher metrics for not including solar, lower ones for including solar. And so you are also allowed, if you are have solar on the home but are not meeting that index, this lower energy rating index, but you are meeting the higher one, you can just model without your solar. So there is that flexibility throughout.
So solar is the biggest thing that can swing the energy rating index. And when I first looked at this, I had forgotten about the envelope backstop. The code is always trying to protect the building thermal envelope. And if you just look at this table without understanding the backstop there, you'll see that you could build a house potentially, or the thought might be that you could build a house that scored maybe 100 on the scale, equivalent to the 2006 IECC, and put some solar on it and drive it down to, in climate zone 5 of 43, for example, there. You could do that pretty easily to get that score, but you still would not be in compliance with the code, because the code, again, is always trying to protect the building thermal envelope, so you have to take into account that thermal envelope backstop, that additional 15% UA, or TC, I guess now that they're trying to impose on this pathway.
Yes. So next, let's talk a little bit about how federal programs are reacting to the 2024. What we've seen from DOE, there's not a final determination about this. Some of the initial assessment, and again, I believe this was before the appeals occur, was that this code was about 6 to 8% more efficient than the 2021. What I've seen is that the final analysis has not been published, and we don't expect that until after the election at the earliest. So it's still going through review, and hopefully that we will see this, what this determination looks like in the future. That determination is important because it also impacts the HUD USDA energy efficiency standards. So for the FHA insured and USDA single family home programs, there's this requirement to implement the 2021 IECC by November 2025. HUD has said that they will accept the 2024 as an alternate pathway contingent on that final determination. So we still need DOE to complete that determination before the 2024 can be accepted. So that's one federal program that we're looking at and trying to understand. The other piece is IRA Energy Codes development funds. Where are those going? When the 2024 came out, they did update their requirements for application to include the 2024 as a qualified code. This is before the final determination. They're saying already, we believe that this is going to be as efficient as the 2021 or more efficient, so it's going to be a qualified code. In that bucket of $1 billion of funding for energy code implementation, there are two key pathways. There is formula funding. This is pretty simply if your state is on a pathway to implement a more advanced energy code like the 2021 or 2024, and they apply for that funding, they will get it. that is, as long as they can prove that they're on a pathway to implementation, they can qualify for that funding. But the formula funding will only allow adoption with a set list of approved amendments, so it won't allow any trade-offs. So if your state or local municipality is amending the code to have strengthening and weakening amendments, you may not qualify for that formula funding, but there is a smaller bucket of funding that is the competitive funding. That also will allow the 2024, and you can have a combination of strengthening and weakening amendments as long as it is still proven to be more efficient than the 2021. So this is an opportunity for states to get some funds to implement better codes, more stringent codes, but it is very specific on how you can do that and what codes are going to qualify. But we are seeing that they're reacting to the 2024 already. Finally, let's talk about 2024 versus 2021. What code should your jurisdiction adopt? And this isn't really a versus, an and or it isn't a or, it's really a what do you think is going to work best? And so these are the key things that I would suggest to anybody looking to adopt either of these codes. Look at your climate zone. There's some climate zones where I believe the 2024 may be more favorable, specifically climate zones 4 and 5. There's some carve-outs for those climate zones in particular that may make it easier to comply. Understand your local construction practices. What are you going to be able to execute on well in that area, and what do these codes require? If you think you can air seal really well, you can get some significant credit for that under the 2024. That might be a good option. Also look at your compliance pathways. The majority of builders throughout the country still are stuck on the prescriptive path. That's what they use, that's how they comply. There are opportunities to push them towards a performance pathway or a modeled pathway, but that's going to take time. And then finally, look at, does your local municipality, do they adopt things unamended? Do they say, nope, we want to keep the stringency of the code as written and make it work as written? Or do they include some significant amendments? And you need to understand how that's going to impact the code. And then finally, understanding the other iCode impacts. Energy codes are one small part of the suite of model codes. So understanding where that is. What I've seen from our team at NAHB is that they don't expect the 2024 IRC to cause any significant cost increases compared to the 2021, but it is something to look at. So I think with that, we're going to finish with pros and cons of what we think the pros and cons of each of these codes are. I think it's really not a versus, but Robbie, you want to take 2021 and talk about some of the benefits you see?
Sure. I think I want to start out a little bit broader, though, because the codes in general, the biggest thing that I kind of rail against when I hear it, and I hear it unfortunately all the time, is that when you're building to the code, you're building the minimum worst house that you're legally allowed to build. And we really need to change our perception of codes, because if you build a house to, even from the 2012 on, and you actually build it to the code, you're going to have a well-performing house. And you see in the presentations from Dean Gamble and other government programmatic building programs that the baseline for those programs is the code, our values and whatnot. And so we have an understanding, they're going beyond that, but it's basically an understanding that minimum isn't a bad word. Minimum doesn't have a positive or negative connotation. It's basically on a national consensus standard saying that this is what we think is appropriate and achievable in a cost-effective way for everybody. So the biggest issue for me with regards to either of these two codes is how it's going to be adopted and how it's going to be amended. And that we need to work on, really, and you need to get involved in your jurisdictions that are adopting these codes so that they don't bastardize the code. The code also is a family or suite of codes. So the IECC doesn't work in isolation from the IRC or the fire codes or the plumbing codes or anything. And these codes have adopted and incorporated really sound building science. So for example, if you amend the blower door test, what is that doing to the ventilation requirements there? Or if you're amending and taking out the requirements or at least the incentives to put in continuous insulation, what does that do with your vapor retarder requirements in the IRC? And are you going to be building assemblies that have drying potential and taking away options and those types of things? The other thing that we should realize is in the code development world, if you look at the 2012, that was a big change in the codes. That's when the blower door testing was added to the codes. And really the 2015 and the 2018 versions of the code are better written versions of the 2012. Pretty much nothing happened there. We had that big jump again in the 2021 IECC with some kind of meaningful changes in the structure and requirements of the code. And to some extent, the 2024 is a better written version of the 2021 with the additional efficiency packages and how that's explained, and the air leakage, explaining that a little bit better, and duct leakage explaining that better. So it won't surprise me much if jurisdictions, depending on if they're required to or not, might jump over the 2024 and wait for the 2027 as thinking that it might be a better written version of the 2021 there. So it's that way. So I think, in terms of which is better or worse, there are things that are good and bad in each of the codes. But I really think that we need to work more on the way that we actually adopt codes and our understanding of codes in each of these jurisdictions. And you all have that ability. You need to get involved in the process in your particular jurisdiction and or on a national level. And as Nathan said, the process for the 2027 is just open, so anybody's allowed to put a proposal in. So if there's something that you don't like or something that you want to add, take that onus on yourself to do that. And the bigger point here is that makes even more sense in your local jurisdictions to get involved in the code adoption process in your local jurisdictions.
Yeah, I will second everything Robbie just said. At the end of the day, I don't think there's a reason to look at these as versus for each other. Both are very high-performing codes that take some significant jumps in energy efficiency. So it's how can you best implement that to your local jurisdiction and meet the goals of those local builders, local officials, and make sure that you have a code that works for everyone. And with that, I think we'll take some questions.
You want to come grab it? Okay.
2018 on the 21 and 24 happen to be?
So I would say I think last numbers I saw, 2021 was about 10% more efficient than the 2018. And then 2024 is another 6 to 8 on top of that. So, 16 to 18% better than the 2018.
You're with NHB, right, Nathan?
Yes, I am with NHB.
Yeah, you're pushing, aren't you?
Sorry?
Are you pushing back a little bit? That's a pretty good jump,
It is.
especially when there's so much focus on affordability.
So I'm going to fight back.
All right, good.
So first of all, the determination is done on the prescriptive pathway of the code. So the first thing when you see, for example, the R60 in the attic and builders go crazy, you have to understand that it's not a mandatory requirement there, that you can use a performance approach to change that R value and make it figure out the most cost-effective way for any particular builder to build the house there. The other thing, I think the bigger change there is with the additional efficiency packages there. And the code it's not on a defined pathway to zero, but it is on a pathway to increase the efficiency and
comfort and resiliency and durability of our national housing stock. So it does in essence have a mandate to increase the efficiency, but to say, I don't like the word stringency per se. It is what it is, and if people have issues with it, they need to get involved in the process there. And NHB, you know, does get involved in the process, and they are trying to. They're doing it I think in like we were talking earlier, in an ethical way. In essence, they're trying to. They're with the understanding that things are going to increase. They're trying to do it in the most cost-effective way possible. So our values, I think, have reached their limit, being able to affect the efficiency of the house, and so now they're moving into additional efficiency packages in order to make that happen there.
Thanks. One more question. In the 27 code, it befuddles me that even in the 21 and the 24, we don't have in that table, the envelope table, for unvented attics. And, you know, you've got above deck roof or envelope, but nothing for that sealed attic. And so that's my request for you guys involved in the process.
Yeah, I would say that also, you know, that's going to take significant coordination with the IRC. So understanding how those are going to work together well, and how we're going to, you know, maintain vapor control, condensation control. I would say that as written, the table does have a definition for unvented attics, but I also understand that you know, venting or the values for the ceiling floor versus the roof deck could change, but I would need to see significant evidence to really push that forward.
The R values are the R values, and you can put them, you know, at the ceiling plane or at the roof deck plane, but you still have to use those R values. So I think what you're talking about is more definition of how you install things, and then you have to go to the IRC for that there. And so again, the codes are a suite of codes that work interactively together, synergistically together to create the performance of the house, and I think that's how it ultimately is working. That's not necessarily recognized. You're right in the code, but right now you're required to put that R value.
Question over here.
I heard that. I heard that the 2024 IECC would have a little bit more of a focus on resiliency. Can you speak to that just a little bit?
So yeah, there definitely is a focus on how do we create durable change throughout the home. There's definitely a focus on, you know, knowing the other code development and perspectives. There's definitely a big focus on flood resistance, wind strength, and all of that, and how that tends to fit in with the IECC. I think there's often been a push that the energy code and requirements can't work together, but I think there are opportunities to make sure that they can coordinate. It is difficult looking at the scope and intent provided by the ICC Board of Directors. Resiliency is an option, or is an area that has been pushed to non-mandatory sections of the code. So we'll see how that continues to grow in the 2027 and how these resiliency, greenhouse gas emissions, and other non-energy related items will impact code compliance and code opportunities. I'm really interested to see how that's going to work. And I don't know if we have a key pathway, but I am curious to see how it's going to work.
I think that that's an example of the biggest kind of conflict that code development has right now, in the sense that the the code world is trying to isolate energy and those ancillary things that impact energy, but also impact other things like resiliency or electrification. That's what caused the peels in essence. And anything like that, if it's going to be incorporated in the energy code, it's going to be moved to an appendix from here on out there. So there's not going to be that direct interaction between resiliency and efficiency, even though there is a direct correlation between the two.
Please join me in thanking Robbie and Nathan for an incredible presentation. They'll hang around for more questions over by the coffee. Thanks, gentlemen.